What if the strongest source of renewable energy isn't on land or sea, but soaring in the sky? Welcome back to MixMind 7090, where future tech meets today's world. Today, we're diving into one of the most exciting innovations in renewable energy, smart kites that fly hundreds of meters above the Earth, harvesting powerful jet stream winds to generate clean electricity. This isn't science fiction, it's called airborne wind energy, or AW, and it's real, scalable, and soaring fast toward the future. The problem with traditional wind turbines, they're stuck on the ground. Standard turbines operate below 200 meters, where wind is slow, inconsistent, and often unpredictable. Meanwhile, just half a mile above us, the jet stream flows with unimaginable power, up to 1,800 terawatts of kinetic energy. That's 100 times more than what humanity consumes today. But how do we tap into that invisible river of wind? Enter smart kites. These aren't your average kites. We're talking about autonomous flying robots, lightweight wings guided by artificial intelligence, sensors, GPS, and real-time wind tracking. They fly at altitudes of 500 to 800 meters, soon reaching up to 5 kilometers, where winds blow 5 to 8 times more consistently than near the ground. And thanks to the cube law of wind speed, even small increases in altitude can triple the energy output. Most smart kite systems today use a method called ground generation. Here's how it works. A kite or drone-shaped wing pulls a high-strength tether attached to a ground drum. As the tether unwinds, it spins a generator, producing electricity. Once fully extended, the kite reels back in using a fraction of the energy, and the cycle repeats. AI algorithms optimize the kite's flight path, usually a figure 8, to maximize power output with every swoop through the sky. It's like a flying turbine, but with 90% less material, no steel towers, and full mobility. Let's look at the companies leading this airborne energy race. SkySails Power, Germany. Their Venyo system produces up to 760 MWh per year, enough to power 400 homes from a single container unit. Kitepower, Netherlands. Born from TU Delft, their 100 kilowatt system cuts diesel use on construction sites by 50% and deploys in just 90 minutes. Makani, USA. Once backed by Alphabet, they experimented with kite-mounted turbines for steady airborne generation, Enerkite and Kite X, each pushing the boundaries of flying energy systems, from hybrid mini-grids to drone-like turbine blades. So why does this matter? Because smart kites offer serious advantages. Lower costs. Current systems are already cheaper than diesel, just 20 cents kWh, with projections under 5 cents as they scale. Portable. Units fit inside shipping containers and can be deployed anywhere in under 48 hours, even on remote islands. Eco-friendly, no concrete, no deep foundations, and minimal impact on land or sea. Consistent output. With capacity factors above 60%, these kites deliver reliable, near-baseload renewable energy. But of course, no innovation is perfect. Regulation. Aviation authorities still don't know how to classify airborne wind farms. Tether durability. High-strength fibers wear out faster than desired, lasting 2 to 5 years instead of 20. Weather risks. Thunderstorms and icing require smart, fail-safe landing systems. Grid integration. Power fluctuations need to be smoothed out using capacitors or synchronized kite fleets. Still, the research is catching up. In 2025, Delft University validated system performance and optimal kite sizes, and SkySails published the first industry-approved power curve, proving 24/7 operation even in stormy conditions. The road ahead is exciting. In the near term, smart kites will replace diesel in mines, islands, and disaster zones. Mid-term, we'll see floating offshore kite farms, no seabed permits needed. Long-term, we're aiming for multi-kilometer altitudes, even tapping into jet streams at 10,000 meters. Experts say we'll reach 1-kilometer altitudes within 5 years. The EU alone could unlock €70 billion in airborne wind investments by 2035. Once a Victorian-era fantasy, high-altitude wind power is becoming a reality. Thanks to aerospace engineering, AI, and visionary innovation, we're learning to harvest energy not from the ground, but from the sky. The wind revolution isn't just blowing, it's soaring. If you enjoyed this, make sure to like, comment, and subscribe to MixMind 7090 for more deep dives into futuristic tech shaping our world.